All right, let's talk about a technology that could literally change, well, everything. It's called quantum computing. And this isn't just a small step forward, it's a massive leap that could solve problems we currently think are completely impossible, shaking up everything from medicine to finance and way, way beyond.
So let's just start with that question right there. Seriously, what if? What if we could actually solve the impossible? That is the fundamental promise of quantum computing. And let's get one thing straight right away. This is not just a faster version of the computer on your desk. It's a completely different way of thinking about computation itself.
So here's how we're going to break it all down. First, we'll get into what makes a quantum computer so radically different. Then we'll look at the massive stakes involved, the incredible upsides and the kind of terrifying downsides. We'll explore the magic behind something called a qubit, see what it can do in the real world, and finally, we'll check out the three main types of these machines being built today. Okay, first up, a new kind of computer. To really get what's going on here, we have to move way beyond the simple bits and bytes that have powered our entire digital world up until now.
This slide really just nails the fundamental difference. A classic bit in your phone or laptop, it's like a coin lying flat on a table. It's either heads, a 1, or it's tails, a 0. That's it. But a quantum bit, or qubit, is more like a coin that's still spinning and wobbling. It's in this weird, blurry state of being both heads and tails at the exact same time. And this is where all the magic starts.
And that mind-bending, spinning coin state, that has a name: superposition. It's this incredible ability for a single qubit to be a 0, a 1, or kind of both, all at once. And just this one feature alone means a quantum computer can explore an absolutely staggering number of possibilities simultaneously. We're talking exponentially more powerful. And just when you think it can't get any weirder, there's entanglement. This is where two qubits can become linked in a very special way, where their fates are totally intertwined. If you measure one, you instantly know the state of the other one, even if it's miles away. Einstein famously called it spooky action at a distance, and it's this connection that lets quantum computers work on incredibly complex, interconnected problems all at once. So all this strange, immense power, what does it actually mean for us? Well, that brings us to the quantum promise and peril. Because when you have this kind of capability, you can be sure the stakes are going to be enormous. And make no mistake, this is not science fiction. The world is betting big on quantum. We're talking a projected investment of over $9 billion by 2030. That's a huge bet, and it tells you one thing. The quantum revolution isn't just coming, it's right around the corner. This technology really is a double-edged sword. On one side, the opportunities are just incredible, creating new life-saving drugs in a fraction of the time, optimizing traffic flow for an entire country, building financial models that are almost perfectly predictive. But, and this is a huge but, there's a major threat. Modern encryption, the very foundation of our digital security for everything from bank accounts to military secrets, could be cracked, shattered almost instantly. So that brings up a really important question. How do you take all these weird quantum properties and actually get a useful answer out of them? Let's pull back the curtain and see how it works in section 3. You see, a quantum computer doesn't just spit out a single perfect number like a calculator. It's more like a professional odds maker. First, you put all the qubits into that wobbling state of superposition, which represents every possible answer all at once. Then, you run these really clever operations that nudge the probabilities, making the right answer more and more likely to appear. You have to run the whole thing over and over again thousands of times and measure the outcome each time. Finally, you look at all that data and find the pattern, the statistical winner that points you to the optimal solution. It's a whole new ballgame for finding answers. Okay, that's the how. Now for the really exciting part. What can this stuff actually do for us? Let's look at some of the game-changing advantages that are just on the horizon. The big advantages really fall into 3 main buckets. First is optimization. We're talking about finding the absolute best solution to puzzles with billions of variables, like creating the perfect investment portfolio or the most efficient shipping network on the planet. Second, simulation. This means creating perfect digital models of complex systems, which is a total game changer for designing new materials or discovering new medicines. And third, machine learning. Basically giving AI a massive upgrade, making it faster, smarter, and more powerful than we can even imagine. All right, last big concept, and it's an important one. The term quantum computer isn't a one-size-fits-all kind of thing. It's better to think of them as different tools for different jobs. Let's look at the 3 main flavors. So you've got 3 main types: Gate-based computers are kind of the all-arounders, like your laptop. They're designed to be universal problem solvers. Then you have quantum annealers. These are the specialists, built specifically for those insane optimization problems. Think of them as being experts at finding the lowest point in a huge, bumpy landscape. And finally, you have topological computers, which are all about being rock solid and stable, designed to be highly tolerant of errors for super secure calculations.
So here's the bottom line. Quantum computing has the power to solve some of our biggest challenges, but it also has the power to break the digital world as we know it. This new era isn't a question of if anymore. It's a question of when. So the only real question left to ask is, are we ready for it?